About joint variations. In the joint variations, we are going to join direct variations and as well as inverse variation. You can say the mixture of joint and inverse variation will give you the joint variations. Like I have stated here, I have written joint variation and inverse variation. Like if in an example, if two of them are going to join, then they are going to form joint variation. To look at the examples, so I have written if x varies directly as square of y and inversely as cube of z. So in this case, x proportion to square of y and inversely as a cube of z, mean divided by z raised to the power 3. So now if we want to bring equal sign here, as all of you knows that we have to introduce a constant ky square over z raised to the power 3. So let us see the next example. If L varies directly as square root of m, now directly to square root of m and inversely as a cube root of n. So L proportion to square root of m and inversely as a cube root of n. Now L will be equals to constant square root of m divided by cube root of n. So let us see some examples of joint variations. So the question is, P, Q and R are related in such a way that P varies directly as square of Q and varies inversely to the R. When P is 36, Q is 3, R is 4, calculate Q when P is 200 and R is equals to 2. So this question is from past paper 2008. So P proportion to Q square and inversely to R. So P equals to KQ square over R. So they gave us P36 and Q3. Let us put those values and then R4. P36, Q3 and R as a 4. So this 4 will multiply with 36 equals to K. 3 square will be 9. So let us divide 9 on both sides. So 9 cancel 9. 9 into itself 1. 9 into 36 4 times. So 4 times 4 will be 16 equals to K. So the next part is we have to put the value of K here in this expression. So P equals to 16 Q square divided by R. So here they said that calculate Q when P is 200 and R is 2. So P is 200, 16 Q square divided by R is 2. So it means 2 into itself 1, 2 into 16 8 times. So 208 Q square. So let us divide 8 on both sides. So on this side it will give us 2 into itself 1, 16, 4, 8 times 5, 40. So 25. So 8 cancel with 8. Here q square. Let us take square root on both sides. So square root of 25 will be 5. So that's your value of q. The next thing is now partial variation. In partial variation, alphabet behaves as partially constant and partially variable. So I have written some examples for you to so that you understand. If x is partly a constant and partly varies directly as y, then we will write by introducing two constants. If x equals to k1 plus k2 y, because is directly. Let us see the another example. If x is partly a constant and partly varies inversely as a square of z. Now in this case, x equals to k1 plus k2 divided by z square, because this one is inversely, that's why it will be written downside. So let us see the next one now. If a is partly a constant and varies jointly mean the product as L and B. So we will write a equals to k1 plus k2 LB, because they didn't tell us is directly or inversely. Whenever it is not informed to you that is directly or inversely, is better you consider it as directly always. So now let us see the last one. If P varies partly as Q. Now here also he didn't tell you because is directly to Q. So we will write P equals to K1 Q and inversely as square of R. Then we will write plus K2 divided by R square. So now all the possible situations for all the examples we have discussed here, from number 1 up to number 4, when they say the product, we will write both of them with one of the constants. When they say varies directly, partly as directly to Q and inversely to another alphabet, then we will write them separate with both of the alphabets. Now let us see some of the questions of partial variations. Question of partial variation is over here. So they said that V partly varies and partly constant to the time taken t. So it means the relation is going to be V equals to k1 plus k2 t. Now they gave us the values here. Velocities of the car are 8 second and 12 second. V is 8 second respectively to the, this is time, 8 second. Velocity will be 9 meter per second. Let us put these values here and to have one equation. 9 equals to k1 plus 8 k2. Now the second one is t is 12 second and the velocity is 11 meter per second. Let us put these values here as well. So velocity will be 11 equals to k1 plus k2 will be k2 times 12. Now we have two equations in which we have to find the values of constant k1 and k2. For that, let us write down that equation here. 9 equals to k1 plus k2 here 8. Let us subtract. When you are going to subtract, you are going to change the sign. Here is plus minus, plus change into minus. Now these signs will be written down, side will be considered. K1 plus cancel with minus k1. 11 minus 9 will gives you 2 equals to 12 minus 8 will gives you 4 k2. Divide 4 on both sides. it will give you 1 by 2. So the value of K2 is 1 by 2. Put this value in any of these relations. 9 equals to, I will be using equation 1, K1 plus 8 K2. K2 is 1 by 2. Here was K2. I have used this equation. So 2 into itself 1, 2 into 8, 4 times. So 4 is adding here. When you will bring it this side, it will be subtracted. 9 minus 4 equals to K1. So the value of K1 is going to be 9 minus 4 is 5. Now put these values in the equation. We have V equals to K1 plus K2T. So K1 is 5, V equals to 5 plus K2 is 1 by 2. So T by 2, 1 times T will be T by 2. So now this is the equation we will be using to find out all the values what they are saying. In the first one they said the relation between the velocity and time taken. So this is the relation between velocity and time taken. So it means with the number 1 we are done already. Number 2, the time taken when the velocity is 15 meter per second. Now they are saying velocity 15 meter per second, the time taken. So we have to find the time when velocity is 15. Let us put this value here. V is 15, 5 plus T by 2. Transport 5 on the other side. 15 minus 5 equals to T by 2. 15 minus 5 will gives you 10 equals to T by 2. So this 2 will multiply 10 times 2 equals to T. 10 times 2 will be 20 seconds. So time will be 20 seconds when velocity is 15 meter per second. So the solutions of partial variations are like this. Now let us see some of the past papers questions.